Hi everyone, welcome to lecture 18 on basic inorganic chemistry. My name is Dr. Teresa Chimambam. For today's lecture, we will study how to determine empirical formula and molecular formula when you are given mass percent of different elements in a compound. Okay, four steps are involved when determining empirical formula and molecular formula from mass percent of different elements in a compound. So whenever you are asked to determine the empirical formula and molecular formula from mass percent of different elements in a compound, you must follow these four steps. And they are: 1. You have to assume that the total mass is equal to 100 grams so that you can convert percent directly to gram. So the first thing is to assume that the total mass is equal to 100 grams. And the reason is for you to be able to convert the percent that is given directly to gram. So after doing that, the next step is then to convert the gram that you have obtained from step 1 to moles. So you have to convert the grams that you have obtained from step 1 to moles using the formula moles equal to mass divided by molecular weight. The third step gives you the empirical formula. When you divide the moles of each element that you have calculated from step 2 by the smallest mole. So when you divide the moles of each element that you have calculated from step 2 by the smallest mole, you will get the empirical formula. The last step, which is step 4, gives you the molecular formula. When you divide the molecular weight that you are given by the molecular weight of the empirical formula that you calculated from step 3. So in step 4, you will get your molecular formula when you divide the molecular weight that you are given by the molecular weight of the empirical formula that you determined from step 3. So let's look at this practice example. A compound with molecular weight 180.16 grams per mole was determined to have 40% carbon, 6.71% hydrogen, and 53.29% oxygen. You're asked to calculate the empirical formula and molecular formula of the compound. So, to answer this question, we follow the four steps that I explained in the previous slide. So, step 1. First, you assume that the total mass is equal to 100 grams so that you can convert directly from percent to gram. So the first step is to convert all percent to gram. So then what it means is that 40% carbon would then be equal to 40 gram carbon. 6.71% hydrogen will be equal to 6.71 gram hydrogen, and 53.29% oxygen will be equal to 53.29 gram oxygen. So now that we have converted percent directly to gram, we then go to the second step. So the second step is to convert gram to moles using the formula moles equal to mass divided by molecular weight. So we need to convert all the grams from step 1 to moles. So 40 gram carbon will be equal to 40 gram divided by 12 gram per mole. This 12 gram per mole is the molecular weight for carbon. So if we do this division, we will get 3.33 moles of carbon, because this gram will cancel this gram and then this mole comes up. So then the answer will be in moles. We do the same thing for hydrogen. Moles of hydrogen will be 6.71 gram divided by 1 gram per mole. This is the molecular weight for hydrogen. So again, the gram cancels gram and this mole comes up. So the final answer is then 6.71 moles of hydrogen. So this is how to cancel out your units. If you keep putting all the units, some will cancel out and you will then get the final unit. So for oxygen, it will then be 53.29 gram divided by 16 gram per mole. Again, gram cancels gram and this mole comes up and the answer is 3.33 moles of oxygen. Right, step 3 is to divide the moles that we calculated from step 2 by the smallest mole, which is 3.33 moles. So for carbon, it will be 3.33 moles of carbon divided by the smallest mole, which is 3.33 moles. So this 3.33 moles cancels this one, and the answer is equal to 1. For hydrogen, we divide 6.71 moles of hydrogen that we calculated from the previous slide by the smallest mole, which is 3.33 moles. So these moles will cancel this one, and the answer is 2. For oxygen, we divide 3.33 moles of oxygen that we calculated from the previous slide in step 2 by the smallest moles, which is 3.33 moles. So this cancels this and the answer is equal to 1. So the empirical formula is then carbon 1, because we calculated 1 here, so we write C. Hydrogen 2, because we calculated 2 here, we write H2. Oxygen 1, because we calculated 1 here, so we write O. So the empirical formula is CH2O. The fourth and the final step is to calculate the molecular formula. And we calculate the molecular formula by dividing the molecular weight that we are given in the question, which is 180.16 gram per mole. We divide that by the molecular weight of the empirical formula that we calculated in step 3. So the molecular weight of the empirical formula, which is CH2O, is 12, the molecular weight for carbon, plus 1 times 2, 2 because there are 2 hydrogen atoms, plus 16, which is the molecular weight for oxygen. So if we add up all these, it will give us that the molecular weight of the empirical formula is 30 gram per mole. So then if we divide the molecular weight that is given by this molecular weight of the empirical formula, this gram per mole, we cancel this gram per mole and we will get 6. The final thing to do is then to multiply the empirical formula CH2O by 6 that we obtained here. So if we do that, C multiplied by 6 is C6. H2 multiplied by 6 is H12, because 2 multiplied by 6 is 12. And oxygen is 1 multiplied by 6 is O6. So the molecular formula is C6H12O6, and the empirical formula is CH2O. So these are the steps to follow whenever you are asked to calculate the empirical and molecular formulae from mass percent compositions of different elements in a compound. Step 3 is where you get the empirical formula, and step 4 will give you the molecular formula when you divide the molecular weight that is given by the molecular weight of the empirical formula that you calculated in step 3. Let's look at another example. So a compound analyzed by elemental and gravimetric analysis contains this percent phosphorus and this percent oxygen. The molar mass was this. You are asked to calculate empirical and molecular formulae. So, step 1, we have to assume that the total mass is 100 grams so that we can convert directly from percent to gram. So converting the percentages to gram, we will have that 43.64% phosphorus will be equal to 43.64 gram phosphorus. So we do the same thing for oxygen. So step 2 then is to convert gram to moles using the formula moles equal to mass divided by molecular weight. So for phosphorus, we will have 43.64 gram divided by the molecular weight for phosphorus. So this gram will cancel this gram, and then we will have 1.409 moles of phosphorus. We do the same thing for oxygen, 56.36 gram divided by the molecular weight of oxygen. So gram will cancel gram, and we will get 3.523 moles of oxygen. So the smallest mole out of these two is 1.409. So we then go to step 3. So step 3 is to divide the moles by the smallest moles, which is 1.409. So this step 3 gives us the empirical formula. So from step 2, where we calculated the moles, we found that the smallest mole is 1.409 moles. So we divide each mole by this smallest mole. So P is equal to 1.409 moles divided by the smallest mole, which is 1.409 moles. So this cancels this. So the answer is equal to 1. For oxygen, we divide each mole by the smallest mole, which is 1.409, and we'll get that these moles cancel this mole. So the answer is 2.5. But because this is not a whole number, we need to find the smallest number that we can use to multiply 1 and 2.5 so as to get a whole number, because the subscript must be a whole number. So that smallest number is 2. If we multiply 1 by 2, we will get 2. If we multiply 2.5 by 2, we'll get 5. And in that way, both subscripts will be whole numbers. So if we do that, we will get P2, because 2 multiplied by 1 is 2, P2. 2.5 multiplied by 2 is 505. So then the empirical formula is P2O5. And the reason why we had to multiply the subscripts by 2 is to make this 2.5 a whole number. If we had obtained 2, there won't be any need to do that. But once you obtain a subscript that is not a whole number, you have to find a way to make it a whole number. And that way is to find the smallest number that can multiply both subscripts to give a whole number. Right. So the next step is the step that gives us the molecular formula. And to determine the molecular formula, we divide the molecular weight that is given by the molecular weight of the empirical formula. So the molecular weight of the empirical formula, P2O5, is 2 multiplied by 30.97, which is the molecular weight for phosphorus. We multiply by 2 because of these 2 here, plus 5 multiplied by the molecular weight of oxygen. So this 5 because there are 5 oxygen atoms. So we'll get that the molecular weight for P2O5 is 141.94 gram per mole. So to get the molecular formula, we divide the molecular weight that is given, which is 283.88 gram per mole. This was given from the question. We divide that by this molecular weight of the empirical formula. So if we do that, this gram per mole will cancel this gram per mole, and if we do this division, we will get 2. So what we do next is to multiply the empirical formula by 2. So if we do that, 2 multiplied by 2, we will have P4. 2 multiplied by 5, we will have O10. So this is then the molecular formula, while P2O5 is the empirical formula. So these are the 4 steps that you must follow when you are calculating the empirical formula and molecular formula from mass percent of different elements in a compound. So to test your understanding, you can try to solve this problem just to make sure that you have understood how to calculate empirical and molecular formulae from mass percent composition of different elements in a compound. Right, this is where I'm gonna end for today's lecture. Please like this video and subscribe, and I will see you in the next lecture.